Today we are talking about remote sensing. So what is remote sensing, type of remote sensing, spatial and spectral resolution, and raster data. So what is remote sensing? Remote sensing is the process of gathering information about an object or area from a distance without making physical contact. So this is done by using sensors that detect energy like light or heat reflected or emitted from the Earth's surface. So these sensors are mounted in tools such as aircraft, satellites, and drones. So when it comes to satellites, is that the satellites orbiting the Earth provide large-scale regular images. When they use drones, the drones can fly at low altitudes for more specific data. And your aircraft captures detailed images from above using cameras or infrared scanners. So in simple terms, remote sensing is like taking a picture of Earth from above to study what's happening on the ground. And this is how it is kind of explained. So what is remote sensing? Using the satellites, the drones, aircraft, and those images get analyzed and the information used for certain purposes. The types of remote sensing images. So you get aerial photographs and satellite images. Those are your types of remote sensing images. So aerial photographs is taken from airplanes or drones flying at low altitudes. These photographs are used for detailed small area studies like mapping farms, roads, or construction sites. And they are usually captured in visible light and are easy to interpret visually. Your satellite images is taken from space using satellites that orbit the Earth. And they cover large areas and can capture data in multiple wavelengths, for example, infrared and radar. They are useful for tracking global changes like climate patterns, deforestation, or ocean currents. So each type of image has its strengths. Aerial photos are more detailed for small areas, while satellite images are better for broad monitoring. Great, so now that you understand that, let's look at spatial and spectral resolution. So what is this? These are two key qualities of remote sensing images that affect how much and what kind of information we can see. So you get spatial resolution and spectral resolution. So spatial resolution refers to the amount of detail in an image. So let's look how that would look like. So this is spatial resolution. The higher the resolution, the clearer you can see what is going on. So it's measured by the size of each pixel. For example, a spatial resolution of 10 meters means 1 pixel represents a 10 by 10 meter area on the ground. Higher the resolution, the more detail. For example, you can see individual trees or buildings. If it has a lower resolution, it has a broader view and you can see the general land cover, but you cannot see as much detail. Then your spectral resolution refers to the type of electromagnetic wavelengths the sensor can detect. Some sensors see visible light like the human eye. And what we mean by that is we can see in colors. While others only detect infrared for vegetation health, thermal radiation for heat detection, or radar to see through clouds or light. Different materials reflect different wavelengths. So spectral resolution helps in identifying land types, vegetation, or water bodies. And this is how it will look like. Here's your visible light. That's what we can also see with our eyes. But other resolutions, when it comes to infrared or thermal, looks a bit different. Then your data types. So there are raster and there are vector data types. So raster data is made up of pixels, like a digital photo. And each pixel contains a value representing information, for example, temperature, vegetation, and elevation. It is commonly used for satellite images and elevation models, and it looks like a grid or mosaic when zoomed in. So in this image, this is what raster data looks like. Your vector data represents real-world features by using points, lines, polygons. It is symbols representing certain things on the map, like weather stations, trees. Lines will indicate roads or rivers, or polygons will represent land areas or lakes. And vector data is often used in GIS to layer and analyze data spatially. So this is your vector data. These symbols are used: point, line, polygon, and when you look at the map, this is what it represents. So this squiggly blue line would most likely represent a river. This polygon area might represent a certain piece of land, and you get various other symbols on a map. Right, so the uses of remote sensing. So why do we use that? Why do we need that? It is for environmental monitoring, tracking deforestation, desertification, or coastal erosion over time. So it's not like over 1 day or 2 days, it's over a period of time, a longer time. For urban development, mapping urban areas, land use changes, and informal settlements. It is also important for agriculture, assessing crop health, irrigation needs, and detecting pests or drought stress. Weather and climate, observing cloud movement from storm development and climate change indicators. And then for disaster management, quickly identifying areas affected by floods or fires, earthquakes or oil spills to plan emergency response. So the uses of remote sensing is across the world to monitor changes, predict risks, and support planning decisions.